Hello students, in this video we are going to interface the internal UART of your LPC 2148, and we are going to see the hello world program. We are going to write the hello world program here, and what we are doing, we are writing this hello world in the program part, and we are going to continuously using the UART, we are transmitting this hello world from the your PC to LPC 2148 to the hyper terminal, and on hyper terminal you will see that this hello world is continuously displaying there. Okay, like other programs, here also we are going to write an embedded C program for the UART, and before that we are going to configure the pins first, and before that we have to select the pins which are going to use as the output pins and input pins, and after that we are going to configure them as input and outputs, and after that we are going to write the program for the UART for displaying an hello world on the hyper terminal. And after writing an embedded C program, once if the program is correct, you have to generate the .hex file for that program, and that .hex file program you have to dump it on the LPC 2148, so that after execution of this program or after running this program you will see the hello world on the hyper terminal. Okay, now we'll start with the program part. So before starting the program part, first we have to see what are the registers we need to be accessed in this UART program. So first register is line control register. So this UART has two registers in all the registers in two pairs, that is U0 LCR and U1 LCR. You can see here, you can see that U0 LCR and U1 LCR, that is UART 0 LCR and UART 1 LCR, that is line control register. Again divisor latch register it is. So this is for divisor latch register, that is for LSB. This is divisor latch for MSB. Again divisor latch for LSB for, again this is 1th, and again this is divisor latch MSB again. So these are available in pairs, that is U0 divisor latch register is available in pair, that is U0 DLL and U0 DLM. So like that we have again U1 DLL and U1 DLM. Once again we have this transmit buffer register, again that is available in the pairs, that is U0 THR and U1 THR. Again receive buffer register is there on the receiver side. So this is available on the transmitter side, this is available on the receiver side, and line status register is there, and to check whether the line is free or not, that is U0 LSR and U1 LSR. And the fractional divisor register is also there, like U0 FDR and U1 FDR. So these are the registers available, and here for this program we are going to use the first UART, that is total 2 UARTs available here. So first UART is since we are using this first UART 0, that's why we have chosen all these U0 registers. Okay, since we have chosen this UART 0, this LPC 2148 has 2 UARTs, that's why we have chosen one among them, that is UART 0. That's why we have written in the program U0 in all the register places. Okay, and this is a serial communication. UART is nothing but a serial communication, and we need this serial communication whenever we are going to transmit the data serially. We are going to use these two UARTs, and here we are going to use this first UART 0, and from this UART we are going to send the hello world to the hyper terminal. So this is the program what we are writing in embedded C. Okay, so after selecting the UART 0, we have to configure the registers first, and after the one configuring the register we are going to write a program, the main program for the UART for transmitting the data. Here we are transmitting the data serially. That means we have to send the data hello world one digit at a time. Okay, and before starting with the UART main function, we have to see the what these registers indicates. So whenever we have considered the UART part, whenever you see an UART, so in that we have two parts, that is transmitter and receiver. So uh, we have to say that there is a successful communication only when first the transmitter should receive the data which is to be sent, and after that the transmitter is sending the data serially to the receiver, and receiver will take that data and store it store it in the memory location. So this is how the UART is performing operations here. And for every UART operation, you can see that there is a transmission section here and there is a receiver section. So in transmission section we have actually we have TX flag available that we are going to use in the program. And after that there is a whenever there is a data available on the bus, that is a data bus, first important thing what you have to remember is what in the transmitter side, the data which is to be transmitted, that is to be stored in this THR, that is U0 THR, that is transmit hold register. So whatever the data is to be transmitted, that is to be stored in this register value. After that register is there after that register have the particular data to be transmitted. After that that data is to be sent to the receiver side. And in the receiver side also, like U0 THR, we have an U0 RSR is there, that is receive shift register is there, and after that there is a U0 RBR is also there. We are going to use all these registers in the receiver parts also. And like TX flag, here also we have an RX flag available. So we are going to use all these in the UART section. And along with this transmission and receiver section, we have a baud rate generator also. So baud rate means that at what rate the data is to be transmitted here. So we in this case we are considering 9600 baud rate, that is bits per second. So the baud rate is here the 9600 we are considering. And we can see that there are many baud rates available in the market. The next baud rate is 19200, and again the next baud rate is 54,000 plus something is there. After that we have a last baud rate to 115200 baud rate is there. So in this transmission we are using 9600 bits per second. Okay, and after that okay, we'll start with the programming. Here you can see that the initial phase we have to configure the registers like what we have configured the register in the other programs, interfacing programs. So here we have defined some parts. Again we are using this LPC 214 series, that's why we have included that header file. Again we have calling one UART interrupt request. You can see that this function is there. So whenever there is a data available, so the LPC 2148 will generate an interrupt request by calling this function. Okay, and after that we have assigned some characters like temp1 to 0 value, and we have assigned the character like receive flag and transmit flag to 0, and we have one pointer also defined here. And after that we have this storing this hello word in the array. Okay, and there is one unsigned integer is there, that is I. Okay, so this is the this is what all we have defined here. After that we have this is the main program. In this main program we are going to configure the registers what we have discussed in the previous slide. So here first we are going to select the pin select 0. So pin select 0 means we are going to select the port 0, that you should remember. We are selecting the port 0 here. So in port 0 you can see that the 05 means value 0101. So meaning of that one is this is P 0.0 and this is P 0.03, 00 and 03. So that sorry, this is not 3, this is 0.02, this is 0.02. So we are using those pins as the 0.0. You can see this, the value, this 5 represents a digit, that is 0101. So this is the 0th bit, first bit, second bit. So that's why we are going to use these pins as the that's why we are going to use those pins as the input pins for the serial communication. Okay, and after that you can see that we have chosen this U0 LCR with this 83 value. So whenever you choose an UART LCR value, that is a line control register, so by which format you are sending the data, so that the format has this value. So for this 83 value we have the format 8-bit data is there, 8-bit data, 1 stop bit, and so for this value see here, for this value 83 value, so for 83 value we have certain format. So if we choose this number, that is 83, the format selected will be the data will be 8 bits, and we don't have any parity bit here, no parity, and along with that we have one stop bit here. So this is the format. This U0 LCR is representing, that is 8-bit data to be transmitted, no parity bit and one stop bit. And after that we are going to choose this value, that is U0 DLL and DLM. Actually that is only one register only. So this U0 DLL is taking an LSB part, and U0 DLM is taking the MSB part. So these are the upper 16 bits and these are the lower 16 bits, and in those upper and lower 16 bits we are going to put this value. So this U0 DLL and DLM value represents the that is to be calculated using the system, that is clock frequency, that is peripheral clock frequency, and the baud rate which you are using. We'll see that how we have calculated here. See here how to calculate this value, U0 DLL and U0 DLM value. So here the system clock what we are using is 12 megahertz frequency. Okay, 12 megahertz frequency it is. Okay, and we are going to divide it by 4, so that what we are getting, that is we are getting 3 megahertz frequency as a peripheral clock, and to that peripheral clock frequency, that is 3 megahertz divided by 16 into what is the baud rate we are using, that is 9600 bits per second. So if you calculate this value, better you calculate it on your scientific calculator. 3 mega divided by 16 divided by 9600. So you are getting the value around 19 point, you are getting the value around 19 point something. So if you convert that 19 to the hexadecimal value, you will get that exactly around 13 value. So that is what we have written here, DLL. So since it is a small value, we have chosen that in the DLL, and in the MSB part we have to take it as a zeros only, all zeros. We have to append the zeros there. So this is how we have calculated the DLL and DLM values. Okay, and after that we have to choose this U0 LCR as 3. So meaning of that U0 LCR is set to 3 here is so that is we are making a D-lab bit. There is one D-lab bit available in the DCR, that is LCR, that is line control register. So that is, we are making, or we have to choose the, we are making that D-lab bit, that is last bit or 7th bit of that LCR to 0 for serial communication. So we have to make that, we have chosen that this LCR value with 3, and after that there is a interrupt U0 IER is there, again that value is set to 3 here, and after that we have to call the vector interrupts first here. So we have this vector interrupt address. So VIC vector address 0, actually there are VIC vector address 0 to VIC vector address 15, total 16 vector addresses are there. So we are choosing the first vector address, and we are assigning that vector with the unsigned long integer, unsigned long, that is UART interrupt we are calling here. And we have to once again in that VIC vector control, it is the second instruction. So that is 0x20, that is the specific for control 0. We are for choosing this 0 control 0 vector, we have chosen this 0x20 /6 means we are choosing it for UART here. So for each function we have one number assigned here. So for this UART we have this number 6, that's why we have used this 6 value. So if you want to choose it for some other PWM, that is for pulse width modulation, you have set different value is there. Again, if you want to use it for some other interrupt cases, we have to we have some other value there. So for this using it as a UART, we have this 6th value assigned for the UART, that's why we have written 6 here. Okay, and after that this VIC interrupt enable, that is assigned with 40 value. So this is depends, this 0x40 value, this 0x40 value that depends on the CPSR register. So we have already discussed, or we have already programmed for choosing the interrupt request. For enabling the interrupt request, we have to load the CPSR with this value. So that is what it is performing. To perform a vector interrupt enable, we are loading this value in CPSR register so that it is enabling the interrupt request. So this is how we have configured the registers first. After that we are going to the main program here. Again the program is going to be run continuously. So that's why we have written this program in a while one, and we have assigned this pointer value is equal to array, that is the in the array you can see what is that array here. So in array we have this hello world, you can see here in array we have hello world. So in that hello world, the first address of this first character, address of the first character is loaded in the pointer, you know, the pointer function, and you can see that there is a while function and it is checking for this, that is pointer not is equal to /0. So meaning of that is, you can see here in hello world, in hello world we have this /r. So that /r represents, that is end of the line or end of the string here. So here you are checking, in this condition you are checking for that end of the string. So unless there is no end of the string, it is performing this operation. So once that reaches the r value, that is slash r, so it will come out of this loop. Okay, so meaning of this pointer function is like that. So whenever there is no end of the string, so it is entering into this um, while loop, and in that case temp1 is loaded with pointer plus 1, and after that u0 is assigned, u0 thr is assigned with a temp1 value. So what is the data to be transmitted, that will be available in u0 thr, and the what is the first value available, that is with pointer, that is h value. So that h value is assigned to temp, and that temp is assigned to u0 thr. So whatever the value is to be transmitted, that value is to be there in the u0 thr part while transmitting and receiving in UART section. So that's why we have loaded this u0 thr with this temp value, that is first value of this string, and after that you can see that there is a while function, tx flag is set to 0. So this meaning of this one is, you can see that this while function has this semicolon. So unless this function becomes valid, so it is unless this tx flag is set to 0, so it will be in this while loop only. Once that is set to 0, after that once again it is making that ts flag equal to 0, and we have certain delay here for the character to be transmitted, and after that for I equal to 0, I less than 300, so there is some delay. After that once the delay is reached, that is 300, I value reaches or exceeds 300, it is coming out of that loop, and once again we have this for loop available. So here we have this wait to transmit flag set. So here what you mean by this while here is, we are waiting for the transmit flag to set. So once that transmit flag is set, again it is we are making that transmit flag equal to 0, and we are entering into the for loop, and we are clearing the flag bit here, that is tx flag, and after that we are entering into the for loop, and once it reaches this value, again it goes to the next value here, sorry, not here, it is going to the first instruction of this function, and in this value again this pointer is assigned with, sorry, it is not going here, so it is going to this file once again that is not equal, it is checking for this condition slash r, that is not end of the string. If it is not end of the string, again temp value is assigned with pointer plus 1. So after that what is the next values to be selected, that is e. So this is the value to be selected. Again that e is transmitted to the u0 thr. Again it is checking for this while tx flag equal to 1. Once that actually when u0 thr is equal to it has some value, that value is having this u0 thr value is having, that tx flag is set to 1. So when that data is completely ready, that the tx flag is set to 0, and after that once that finishes that once it checked this value, again that you have to reset that tx flag to 0, again that it is going to perform a delay function. Once again it is going to this while loop. So like that you will be getting the hello world, you will be getting the hello world on the hyper terminal there. Once it reaches the hello world, again it comes up this loop, and once again there is a while one. So once again it starts with the hello world execution. So like that this program is going to execute the hello world, it is going to execute this program, and you will see the hello world line or string continuously displaying it on the hyper terminal there. Okay, and before that before transmission and reception part, you have to there must be an interrupt part available. So without this UART interrupt, it is not going to transmit or it initiate the UART transmission. So here also we have to assign this temp value with U0 IIR, and after that this temp value is equal to temp into 0.06. We are multiplying that bit and we are checking for this temp is equal to 2. If temp is equal to 2, then again we are setting that TX flag to F value. Initially we have reset to 0. Now we are setting that to FF, and there is a VIC vector address is there. Again we are we are assigning that with the 0 address. So like this wide interrupt, once you can see that in the main function here. So once the program execution starts, so first thing what is to be this is the first function to be called. So it is checking for the interrupt there. So at the starting only this part will be executed, because this is the function they have called first. So they have assigned temp with these values U0 IIR and temp and 0.06 means we are performing bitwise AND operation between the temp, and we are choosing only 06 values, that is 0110. So this P0 456, okay, P 0.5 and P 0.6 we are choosing here, and since we are checking for temp is equal to 2, and initially we are setting that transmission flag is equal to FF here. We are keeping it high and we are assigning the vector address to 0 here, and after that once the execution of this wide function over, it will go back to the main function here. Okay, so this is going to be executed only once, that is for calling the interrupt. Once the interrupt is called, it is going to execute the instructions like this. After that it is enter the main function, that is int main. So here we have defined the registers to be set first. What are the registers we have used for the UART communication, and after we have chosen these values, how we have chosen these values we have discussed, and here also we have to enable that vector interrupt by making 0x40 for vector interrupt by putting that value in the CPSR, and this 6 is for we are selecting the UART device, that is the 6th device, that's why we have chosen that number, and here also, and this is how the program is going to execute here by pointing this. So you are checking for the /r here, so end of the string. Unless there is no end of the string, this is going to execute. So like that for each value of the string, that is first H, next L, E, next L. So each value of the string is first stored in U0 THR, that is assigned by temp1, and after that initially in the interrupt part here, in the interrupt function what we have discussed here. So here we have this TX flag is set to 0, but after in the main function we can see that in the main function we are checking for that. So initially that TX flag is equal to 1 here at the time of initially that TX flag is equal to this at the time of this, and we have to wait for this unless that TX flag is equal to set to 00. So that is what it is performing here. So when that transmitter is ready, so immediately this will be reset to 0 by the UART itself. After that it is coming out of that loop, so that you have to remember. And once again that TX flag is set to 0, and for this for function, so that is we are keeping a delay in between the so we are keeping this delay in between the characters, and this is how we are serially transmitting once this program is executed once, so that means we have successfully transmitted one character. So after that, so like that we have to execute total hello space world is there. So total 11 characters are there, so including space. So to execute this hello world string, it is successfully executing 11 times, and after that it is performing it once again. So like that it is in a while loop, that's why it is it is in an infinite loop, that is why it is continuously transmitting the hello world to the hyperterminal, and we can see that on the hyperterminal on your computer screen. Okay, and here we are using the internal UART of the LPC 2148. Okay.